Welcome all the EDTV viewers. Very happy new year to all the viewers. Today I am Moshami Pal from the EDU I welcome our very prestigious guest, very famous international personality, Prof.M.M. Pant. He is one of the pioneers of our Indian education. Welcome, sir, in education channel EDU.
Thank you, Moshami. It's a pleasure to be here, and I look forward to an interesting conversation with you.
Yeah. It's an absolute pleasure and honor to me to welcome Professor Sir once again for sharing his guidance and expertise about the future careers in machine learning and artificial intelligence industry. Before starting today's topic conversation, let me take an opportunity to brief his educational profile and the extent of work he has done for the education industry. Professor Pant is a PhD in computational physics along with a professional law degree, has been a practitioner in the field of law, IT-enabled education, and IT implementation. He believes in the maxim that convergence between various media and technologies would fundamentally alter the way learning would be created, packaged, and delivered to the learners. His current activities are all directed towards actual implementation of this new age educational initiative. Professor Pant has been the Pro-Vice Chancellor at EDU, Indira Gandhi National Open University, and on the faculty at IIT Kanpur, as well as he has been a visiting scientist to research centers in Italy, England, Germany, and Sweden, and has delivered international lectures with about 80 published papers to his credit. With his interest in law, backed with practicing of law in a high court, and his basic training in science and IT, Professor has been particularly interested in the cyber law, patent, and trademark issues. Sir, first we would like to know how is machine learning related to the artificial intelligence?
Very good. So, machine learning is a subset of artificial intelligence. The idea of artificial intelligence came up shortly after computers were created. So, computers were created and they could do what you could call various kind of calculations, and that's why they were called computers. And right around that time, computer scientists started thinking that can they do more than that? Can they do something? And there is a famous person called Alan Turing. He coined what is called the Turing test. So he said, if you are interacting with a machine and your interaction is such that you cannot distinguish whether you're talking to a machine or a human being, then that passes the Turing test of intelligence. So the idea of intelligence was that much of what humans can do, if the machine can also do, then it is artificial intelligence in some sense. So there were many approaches to artificial intelligence. Is a old field. It was born somewhere in 1958 at a famous conference in Dartmouth. And at that time, actually, people were so optimistic. They thought, oh, in a few years, we will do everything. But it didn't happen. There were lots of problems coming in. And therefore, various approaches have been tried for artificial intelligence. In the days in the 50s and 60s, they were looking at something called expert systems and rule-based expert systems. And all AI was based on expert systems. And there were programming languages like Lisp and Prolog and so on and so forth, which were there. But it did not make much progress towards real problem. We'll go into that reason again. Mm-hmm. And then there was what was called a disappointment with AI. It is often called the AI winter. People thought there is no point in putting money into this. Nothing much practically useful will come out of it. It is very good for computer scientists and computer programmers and mathematicians, but it had nothing to do with usefulness for ordinary people. It's only in the last couple of years again that practically useful things have started happening. And that started happening when they started using machine learning as one of the major methods of doing artificial intelligence. Within machine learning also, there are some further categories. And I will try to explain it in one very precise thing. But so, as you know, computers work on algorithms.
Yes.
An algorithm is a set of instructions which you give to the computer, and normally the way you solve a problem is somebody knows how to solve the problem. He writes an algorithm for this. Then somebody who knows the programming language writes in the programming language that you want, and then it gives you feed it to the computer with the programming language. Programming languages have changed over the last 60 years from Fortran and COBOL and Pascal and BASIC and C and C++ and Java, and now of course it is most popularly is Python. But all these had things where you had a program and it was executed again and again. The new thing about AI and machine learning is that this algorithm is now changed to what is called the learning algorithm. Now, the learning algorithm, and I will share with you the most formal definition in a book by Thomas Mitchell on machine learning. The Thomas Mitchell has a very famous book on machine learning. It's almost a basic thing. And I'll quote from that because anybody who knows it will say I'm quoting from him. So I might as well acknowledge that I'm quoting from him. So Thomas Mitchell's book, the definition of a learning algorithm is given as a learning algorithm for a given task T with performance measure P is such that the performance measure P improves with experience E. This is the essence of machine learning. So first thing is, it is for a given task. So whatever task it is doing, for that it will do, but won't do it for something else. So for example, if it is face recognition, it may not automatically do voice recognition. You'll have another algorithm for voice recognition, another algorithm for something else. So it is for a given task. And then there must be a performance measure of the task. You cannot leave it. This will make you happy. No, that is not enough. What is the measure of your being happy? How can I say you are now more happy than what you were before? So there has to be a measure of a task. And then it is saying that when there is a measure of a task, then the performance will keep on improving with experience E. And what experience means? More and more data. The more data you give, the better the algorithm will become. And I can go on, but I'll rather pause and tell you that there are various ways of doing machine learning and so on and so forth. So maybe it must be, we can have a pause and you can now talk of another question.
Sir, as we are talking about the information for the students, basically who are into the 12th grade now, because they are very fancy about their upcoming machine learning and AI future.
Yeah.
So
Yeah.
in that case, sir, nowadays I see that people are very crazy about the robotics industry. So if you
Yeah.
can put some lights on that robotics.
Yeah. So the difference between a normal computer program is that and robots is that in a normal computer program, your input is given to a machine through whatever method, whether you type in or scan in or show an image or whatever, so on. The computer does the processing, and the output is also on a screen or a printout. In a robo, what is happening? The input is coming through some environment and action is being done, and the output is some mechanical action. So the robo may be moving, or it may be cleaning, or it may give you a cup of coffee, or whatever. So it is not only on the screen, but inside the processing is the same. Now you can have a robo without AI. As I said, a traditional algorithm, it does the same task again and again. So it can keep on opening door for you, etc., etc. Or you can have a robo which is running on AI. So it can do, let us take, for example, you normally open your phone with a face recognition. Yes. The camera does not. So there can be a face recognition robo, which if it recognizes your face, welcomes you and say, welcome to my home or office or whatever. And if it doesn't recognize your face, it says, please, you can't come into this building. I don't recognize you. So that becomes a robo with AI. So you will have both kinds of things. Just like computer programs will be normal computer program and learning algorithm, which means AI. Similarly, there can be robots, and then we have so far seen robots typically human-like and doing human tasks. But for example, there is something called a drone. The drone is a robot which flies. The drone is a robot which flies. And again, it can be with AI and it can actually recognize your face. Today, now, for example, the police is able to send drones and identify the people they're looking for. So their face is fed into the program and the AI is able to recognize the face and identify a person and send information as that is required. So the two are very much connected. It is just a question of where the input is coming from and where the output is going.
One another very small question, sir, for today. I will ask for you. Sir, in upcoming corporate area, so
Yeah.
what is the best uh, outcomes do you see for the IT operations?
See, the point is the future is both very interesting and also very challenging, especially in the field of IT. If you remember, I ran through all the programming languages that have happened in the past. And I have seen them before my eyes. My first language was Fortran. Learned COBOL, Pascal, Basic, this, etc. This is the tragedy of being in IT. Things change so fast. You cannot say, I have learned one language and I will live forever like that. So you may be a great hero in Fortran, but if Python is the language of the day, then who cares? Okay. And this is applying to all kinds of aspects. So one of the things about IT is there are great rewards, but it is very short-lived as well. Just like, sports heroes, tennis player, this, that, they're celebrity for a time, but for a very short time. Very soon they're told you have to retire, you are no longer relevant, etc. Yes, yes. So the thing about IT is you have to constantly learn, constantly update yourself and keep on doing. If you think that I have learned this and I will live happily ever after, that will not happen. There is no happily ever after in IT. You have to continuously keep on doing. And this AI is actually going to make it both ways. It will allow you to do a lot more than you could do, but it will also replace a lot of you. They are already coming to a stage. If you have seen some of the latest news, they're saying in future we won't need human programmers. So that learning algorithm will learn how to write a program. After all, this is what we did. We learned the syntax, the vocabulary, the structure of Fortran, and then COBOL and Pascal, etc., etc. The machine will learn it because now it is a learning algorithm. So it will learn how to program, how to code, how to do, how to make a website, and so on and so forth. So this is one of the big things that is going to happen. That things which you do by hand today will become more and more automated tomorrow. But there will be a lot more to do. So it is not that there's a dearth of the things, because there are so much more to do and so many more things which are where both AI, machine learning help. So eventually, rather than focusing on a language or a technique, it is important to become a problem solver. So somebody asked me, what is the career of the future? And I said, the career of the future is a problem solver. What area you solve the problem in is a matter of your specialization. A doctor is a medical problem solver. A lawyer is a legal problem solver. Yes. Some politicians are an election problem solver. So the point is, you have to bring all the knowledge that is needed to be able to solve problems. And this is what is going to happen. Since problems will always be there will always be scope for people who can solve problems. Big problems, small problems, important problems, etc., etc. So versatility becomes the important thing. Earlier, the approach was narrow specialization. As you said, very early, you start deciding, I want to do this or I want to do that, etc. Today, it is an idea that you have to learn a lot of things, learn as many things as interest you. They may not look immediately rewarding, but you will find that it becomes rewarding. For example, now today in the IT field, design has suddenly become more important than technical functionality. And Apple's success was because of the design element. Otherwise, MP3 players were available for a very cheap price from China. Apple iPod was basically an MP3 player, but it changed the whole thing. The way you look at a phone, Look at the phone of yesterday that we had, that black phone with this thing, etc., and the phone of today, including the way we interact with software. See, earlier software interaction was very complicated. Today, the user interface, user experience, all these become much more important. So technology goes into the background. You have to know it. There is no future without understanding maths. But it is the experience that is kind of, and also the integration of various fields.
So thank you, sir. You have given a lot of advices, I know. So this, all the advices, our students and professionals, everyone, they will follow, and they will follow their problem solving areas, and they will be energized. So thank you, sir, with us.
Thank you much. All the best.